If the circuit breaker mechanical devices or electrical relay devices fail to operate after a fault or do not operate quickly enough, then a backup system is designed to isolate the fault. The backup system causes the transformer protector, TP, to open, which interrupts power to all customers fed by a transformer bay. There are many possible causes which could interfere with the proper operation of circuit breaker 122. For example, an electronic component may have failed in the circuit breaker, or a wire may be broken in the relaying system. When level 1 relaying does not work, a backup level 2 relaying system becomes activated. By design, the Zone 2 relaying system does not operate as fast as Zone 1. Zone 2 relaying is a backup to Zone 1 relaying and affects many more customers. When Zone 2 operates, the fault on the system has a magnitude and duration indicating that Zone 1 relaying has failed to isolate the fault. Fault current is sometimes an extremely high rate of flow of electricity and stresses the transformer before it is interrupted by Zone 2 relaying. The stress is internal to the transformer as it delivers more current than it is designed for, are mechanical stresses caused by strong magnetic fields. These mechanical stresses inside the transformer are comparable to the mechanical stresses which occur in a car drive shaft when a teenager floors the gas pedal, peeling out and burning tire rubber on the pavement. Zone 2 relaying is designed to activate as a backup to Zone 1 when Zone 1 fails to isolate a fault from the electric system. The jargon used to quickly describe the many problems which could have caused Zone 1 to fail is sticky breaker. This phrase literally describes one of the potential problems, lack of circuit breaker mechanical lubrication, and is applied to the wide variety of problems in which the Zone 1 relay operation does not open the circuit breaker. When Zone 2 operates, the Stapley transformer protector, TP, opens to eliminate the fault current flowing through the transformer. If not for the TP opening, the transformer, designed to feed 22 megawatts, could be feeding, say, 30 megawatts into the fault. Transformers, cables, and other devices can be damaged from delivering excessive power levels. Note that the entire transformer bay is de-energized when the TP opens, including all the loads fed from the 5 circuit breakers in the switchgear. When Zone 2 operates, there are 30 to 40 SRP employees working together to restore power to the thousands of customers experiencing the outage. DOC system operators, operators for analysis of the fault, coordinators, troublemen, customer service employees, the test crew, engineers, and others each have a role. Most of these employees will not physically talk to each other, but will each play a predetermined, planned role in the job of restoring power to customers. It is like an orchestra, with each of the 40 musicians contributing to the overall program. The next step is to rack out the circuit breakers 122 and 123 and all the other circuit breakers in the switchgear to isolate the transformer from the electric system. Racking out a breaker means to disconnect the breaker from the electric bus on both the supply side and the load side, creating an air gap. The air gap isolates the transformer supply circuits from the customer load circuits. When Zone 2 operates, just like when Zone 1 operated, I must locate and isolate the faulted area from the electric system so that the fault does not create another problem when we bring the power back on. At this point, with the circuit breakers 122 and 123 racked out, and all the other circuit breakers racked out, and the fault completely isolated, I work with DOC to close normal opens, which allows Stapley Bay 2 loads to be fed from Reed Bay 3. Note that Reed Substation is now supplying power to many of the loads previously fed by Stapley. There are a few hundred homes still without power on the far side of the fault from Reed. These houses will remain out of power until the transformer testing is complete. Minimum 12 hours for full test results. and circuit breaker 122 is racked in and reclosed. Another option for restoring power is to install temporary wiring around the faulted area, called a shoe fly, to supply power to the remaining houses. In any case, it will take 10 to 12 hours to supply power to the remaining houses without repairing the fault. Repair of the faulted equipment could take 24 hours or more. Depending on the customer load at the time of the Zone 2 relay operation, Read Bay 3 may be unable to serve the additional circuits. If that is the case, additional switching, not shown, will be required to transfer some of the added load from Read Bay 3 to other substations. The outage response team is working intently to verify the health of the transformer. Re-energizing the transformer is the quickest return to power for remaining customers during a Zone 2 outage. After the Stapley transformer test, if the transformer tests good, the TP is reclosed and circuit breaker 122 is reclosed. This restores service to all customers affected by the Zone 2 fault. Whatever the path to the quickest solution, SRP customers will all be returned to power as quickly as possible. You have seen that the SRP system is designed with controls, wiring, transformers, and circuit breakers, which allow a substation to provide backup electrical service to another substation. Redundancy built into the electric system and employees skilled at outage restoration are fundamental elements of SRP reliability.